pull out the saving part 2 stuff for us to check. Yeah, we forgot to hand that out.
I was scared. I was like, oh, no way.
Bro, we should be logged into our computers.
Do you know how hard it is for me to do this legal form?
You made choices. Go ahead and log in later. So Desiree is here. She just tardy to class.
Yes, that's very scary.
Desiree.
And Carol's
You know that's a tardy, right? Okay. Kirill, you know that's a tardy, right? Come on, man. What? Has the bell already rung?
Why did the bell ring at 12:06? Just ring at 12:07.
I mean, regardless, y'all came in at after 12:07:30, which is when it's really supposed to ring. Y'all need to get to class on time. Like, if you have to use the restroom, at least come and say, hey, Mr. Kenny, I'm running to use the restroom, and I'll tell you to run quickly, but I won't count you tardy.
Like I did. How is my password wrong? Okay.
Going along to the laptops, get the Desmos, pull out your part 2 stuff and check.
The 13th? 14th.
No, yeah, okay.
Yeah.
Has anyone seen Chris or Devin today?
I've seen Chris and Marcus. Who's the Marcus?
I think Devin always do.
No, those two are unfortunately having a bad influence on each other.
They're best friends. No, Devin's not here though.
I thought you just said you saw him in the hallway.
He's right here.
I told you.
I don't know.
Gentlemen, why are we late to class?
The bathroom.
The bathroom. No, you asked for permission to go to the bathroom, and then I can say yes or no, and then I won't count you tardy. You just show up late, you're tardy.
My computer.
It's only 3 tardies, and then you're getting a write-up. I assume that's not what you want. Is that fair?
Just go ahead and log into the laptops, get the Desmos, pull out the part 2 homework. You can check if you did it.
Come on, y'all, get your homework sheets out. Let's go.
I'm gonna read what I was supposed to do last night. And what do you think?
We messed up and didn't give you the 6.4. We're adjusting the homework tonight as a result. I just need to see this.
It was the
Hold on. Why are you connecting this, which goes down here, with this? This goes together. This goes together. Those are 2 different problems.
No. I thought this one was...
A problem I rolled it.
No, because this is... Oh.
Oh.
No,
So that'll be something we can retry.
Shelby. Shelby,
Get your homework sheet out.
No, because that's the thing I messed up on yesterday.
Good job.
We got no owl over here.
Alright, so Carell was tardy.
What? We didn't get a chance
Chris
to
was
vote
tardy.
yesterday. Who wants chocolate chip and
So
who wants
first tardy, Chris,
sugar
but that's a
cookies?
whole lot of
I don't care about your
absences.
birthday. Look at it.
You already said your birthday.
We have been over this.
That's your second
6th
tardy.
grade used it to do
How much?
work.
Whatever.
We talked about
They
this.
messed up my cross too.
Devin?
Don't mess it
They didn't
up.
mess it up.
They barely touched it.
Yeah, it is.
They even created a boundary for it.
Yeah.
You can't get rid of Jesus.
Yeah, they were respectful enough not to get rid of Jesus.
And my kitty book.
And the king.
Where else he came around it? Oh,
Dude, we even told you the
the
answer
big
to
old
this
green
mistake.
thing. Lord.
Alright, I need everyone's attention quickly. Hey, please stop talking and listen. Really quickly, raise your hand if you did do part 2 for Monday and for last night.
I circled the answer, but I didn't put the justification on it. That was my problem.
Okay, so the whole thing is we need justification. So I got 2 of us who did it. I'm going to go ahead and tell you the same thing that I've told every other class. You have 1 last night. You are accumulating homework because I am delaying to give you 1 more chance to get this crap done. But that means that you're getting more homework every single night. Y'all have literally an entire 25 minutes to get every bit of homework done, and you could easily do it every single day. In this class with the teachers that can help you. We gotta start doing our homework. What?
Oh.
Did someone forget to put up their phone? Chris. I guess we need to check that really quickly. Kelsey, you're in 25, right? Chris 3. Devin 5. Layla 7. Shelby 11. Jalea 13. Jalea, do you not have a phone with you?
She's gonna go put it up.
Okay. Corel 15. Desiree 19. Peyton 23. Yes, ma'am.
Mike, can I get the computer?
Okay, hold on one second.
Alright.
Y'all, I cannot emphasize this enough. I talked about it with a student earlier today in a different class. Is it frustrating trying to do homework that you feel like you don't know how to do?
Yes.
Yes, I get it.
And that's me right now.
But I need to point this out. Every bit of the Part 2 homework is review from what we have done earlier this year. None of the Part 2s are new whatsoever. You need to be doing the Part 2s because one of the biggest issues for a lot of students is they forget what they've done in the past, so it makes it harder to learn math in the future. So start doing the Part 2s. It's going to help you review and be better prepared for the later stuff that's coming up in math. Everything I do is by design to help you be better prepared. Can you become the best mathematician, the best math student that you can be without doing any homework? And I know that y'all buck at the idea of doing 5 math problems in a night. I get it. But I need y'all to understand, legitimately, what my teachers would do is say, okay, Nathan, do numbers 1 through 30 even. Or numbers 1 through 30 odd. Which came out to be 15 questions in a single night. I'm asking you to do 5. I'm asking you to do something to help you learn how to do math better. I need y'all to do it. You cannot become the best mathematician, the best math student, earn the best grades until you start to do these things that we're asking you to do. Homework matters. And effort matters. Really.
What?
Well, why are you laughing?
Because my thing, it says I'm 411.
I don't believe you. That's why you were laughing. Are there any questions right now?
Can you define the word mathematician? Because you use that a lot, but I don't exactly know.
What if I don't want
A
to be
mathematician is a person who does mathematics,
I don't
who
wanna-
uses mathematics.
I don't want to be one
No,
of
because
those.
so many,
Huh?
I'll let Peyton finish his thought and then we'll get to Shelby.
I was going to say, so many, you look at people in history, that person's a mathematician, that person's a mathematician. What exactly is it?
Person who uses mathematics. Now, usually when they talk about mathematicians in history,
These are pretty good at it.
these are mathematicians who are really good at it and usually developed or invented or discovered a new mathematical principle. Right, like Leonard Euler, Kinney's Rising Oilers, he was the guy who first really understood the natural number and developed something called the natural logarithm, things like that. He also developed our modern understanding of what a function is and different details like that. But a mathematician is just someone who uses mathematics. And at least while you're in my classroom, you may not want to be a mathematician, but you are a mathematician. Shelby, what's your question?
Did you receive an email from this part about me leaving during
Not yet, but I can check it yet. Alright. We got homework to do tonight. Hopefully we'll end class a few minutes early so you can start it during class, but that means we will be doing that homework during class. Guys, I need y'all to do your homework. Plain and simple. I can work with a student who does not earn the highest grades and struggles mathematically. I cannot work with a student and help them out if they don't do the work. You gotta put in the effort. You gotta show me that you want to learn.
So let's go ahead, we're going to be working on 6.3 today, so let's go and plot 6.3, that's what we worked on Monday. So let's have 6.3 out, ready to go. That's that task that we worked on Monday. So that's what we'll be looking at today. So we're still looking at quadratic functions, and we're looking at, yesterday we talked a lot about doing a quadratic function in explicit form. Today we're going to talk about both explicit and recursive. So first we need to think about what we remember about recursive equations for quadratics. So how do we write the recursive equations for our quadratic? Or recursive equation in general?
You always start with f of x equal to f of x minus 1.
Yeah,
The
that's how
recursive equation is something that relates to current and previous, so it's defined the next term. Not
Exactly.
necessarily,
Good, so this is how every recursive starts, that's perfect. F of x equals f of x minus 1. Then what comes after that?
The rate of change, whatever.
The rate of change, alright, so now we're looking at the rate of change. Now what kind of rate of change does a recursive have?
It has two sets of differences.
Two sets of differences, okay, so we'll look at that, first set and second
And
set.
it has a linear rate of change.
Good, it has a linear rate of change. So that means that the rate of change is additive, so here we're gonna add the rate of change in this recursive equation. So now Peyton mentioned that we have the first differences and the second differences.
You always
Now-
go with the second.
Hmm?
You go with the second difference.
So I was gonna ask, which is the first or the second, the rate of change?
Second.
Do we all agree with that? Do we think it's the second? Hearing a lot of yeses and nos. Is the second set of difference the rate of change or the first set of difference? the rate of
Second.
change? Peyton thinks second.
Because the second's
I
consistent.
think it's a
the
trick
first one's
question.
not. The first one's not consistent, that can't be a rate of change, it's not changing at any specific rate, that's not possible.
So when we're talking about a linear rate of change, we know it's additive. Is it constant additive?
Yes.
Are we sure?
No, actually it's not, okay.
It's not. So a linear rate of change, a linear function has a constant additive rate of change, but a linear rate of change, it's going to be this right here, this first set of differences.
So
that-
it goes on the person.
It's the first set of differences. That's our linear rate of change. Because linear is additive, but it's not constant additive. We're talking about the linear rate of change. So we need to think about how we can find an expression that represents this rate of change to be able to put into our recursive equation. So do we remember how to do that?
Yesterday we did y is equal to negative x squared plus 36.
Okay, so that was our explicit equation, which we will talk about, but what about recursive? I don't think, so yesterday we focused on explicit, but how have we in the past done a recursive of a quadratic? How do you find that rate of change?
What? Sorry, I was trying to log into Dismos.
So we have this linear rate of change, and we need to be able to find an expression that represents it to put it into our recursive equation. Do we remember how to do that?
Yeah. Equation of a line. Something like that.
What?
Equation of a line.
Equation, okay, so equation of a line, so we can find an equation that represents this linear rate of change. How can we do that?
Okay. We're doing the f of n stuff.
Yes, we're looking at recursive, so f of x equals f of x minus 1, but we need that rate of change. That's what
Oh,
we're looking at. We need the rate of
It's
change.
it's a plus 4.
Plus 4 is the constant additive. We're talking about this first set of differences. What we talk about, that's the rate of change. And we need to find,
Oh.
so we need to create a second table
Oh yeah.
for this linear rate of change.
Yeah.
Now, when we create that second table, we're going to start with the second term. So negative 1 goes with this difference of negative 10. So it's not going to be negative 2, negative 10. It's going to be negative 1, negative 10. We always start with that second term. And then 0, negative 6, and 1, negative 2. So now from here, now we need to find an equation, that linear equation or linear expression that represents this table. How can we do that? I know we know how to do that. We can use point slope. Alright, so what's our slope here?
Plus 2.
Plus 2?
Oh, wait.
4.
4. Plus 4. So our slope is 4. So we have y equals, so point slope. So y equals 4 times, now, what point do I want to use?
I want to use one that has a positive number.
So maybe like 1, negative 2?
Yeah, do that one.
Okay, so x minus our x, so 1, and then plus our y, which is negative 2. So now
Yep.
this
That goes at the end of the thingy thing.
right here, this 4 times x minus 1 minus 2, that's what goes in
Right there.
to the end of the recursive equation for that rate of change.
Yep.
Alright, so that's kind of what we want to be thinking about, because we're going to be looking at creating a recursive for a quadratic in this task. This is how we want to do it, this is how I want to think about it. Are there any questions on how we did that?
I When you say minus 2, why did you say minus 2?
So our point was 1, -2. That's the point we chose.
Right.
So, you know, when you're looking at point slope, we do x minus x1, so x minus our 1, and then plus our y1, and so plus this -2, which is the same as saying subtracting 2. Does that make sense?
Yes.
Okay.
Michigan, how confusing.
Hey, what can I title my graph on Desmos? What is this? Is that for this?
What graph, is it a new
Yeah,
graph or
this is
graph
just an
same
example that we
This is just an
created.
example.
Oh yeah, I know. I'm not talking about that, but the one we did yesterday about the rainbow.
Yesterday was 6.4.
Okay.
Yeah, remember we turned 6.4 in and you're working back on 6.3 today.
Yeah. So this is what we'll be looking at.
Oh,
So
we supposed to turn this in yesterday?
6.4.
we were supposed to turn in 6.4 yesterday.
Yes. Now, I did tell you all if you did not complete 6.4, you have until tomorrow to complete it and turn it in.
Okay, I have to turn it in then.
I think you should have done things, because when I look up anything else, it works.
Oh yeah, I remember turning it in.
Okay, so we're going to be looking at, you know, expressing the quadratic function in both explicit and recursive forms. We went over how to do recursive, and then yesterday we talked a lot about explicit. We'll continue to talk about that today. So, you know, looking back at 6.3, we started this on Monday, so we were looking at the situation when he was doing the push-ups every day. So at first, we looked at this diagram where we saw it was adding 2 every time. So we created a linear function for it. But once we got to this new situation, he was looking at the sum of all the push-ups he's done through each day. So the table was, looking at this, we had our days and our push-ups. So on day 1, he still did 3. Well, on day 2, now he did 8. We were taking the sum. And then day 3, 15, so on and so forth. So we're looking at the sum of these push-ups, and we found that it was a quadratic function now instead of a linear function. So what we're going to be working on today, did we all finish number 3 and number 4 on Monday? Did we always start working on number 5? I know it looks like Shelby did. Yes, okay. So, you know, we looked at 3 and 4, so now today we're going to be really focusing on 5 and 6. So for number 5, this is essentially exactly what we just talked about. You know, model total number of push-ups that Scott has completed on any given day, include both recursive and explicit equations. So that's what we're working on. So start working on your groups on creating those equations for this situation. Are there any questions before we get going? On what we're doing? No? Okay, we'll go and start working on your groups, trying to create these 2 equations. And if we can finish this before class ends, which last class did, you'll have extra time to do some homework, so you don't have to do it tonight.
Can we just use the recursive and explicit that you gave us yesterday?
We didn't finish number 5. No, yesterday was a whole different task. Yesterday was 6.4, now we're doing 6.3 right now. You guys
Okay.
That's 6.4.
Okay.
Looking at 6.3 right now.
You're also looking at 6.4, bud.
We were looking at 6.3, now what we did yesterday,
That's 6.4.
what we did Monday.
Ah,
You
shit.
need 6.3. I'm talking about the graph on Desmos. That's 6.4.
Dude.
Okay, number 5, come on class.
Class?
I already did mine actually, so number 6.
No, you didn't.
I did so. Yes,
You gotta find the explicit now. But how did you, first off, how did you find that equation?
I don't know, I think you worked it out
Tell
together.
yourself to shut up.
Did I?
Yeah, we made,
Oh.
I'm thinking that we're gonna just let Friday be the thing for them to work on
What did you put down here?
So tomorrow is assessment and S task, and then
Or-
Friday is missing materials. Maybe. Second, what else would we want to do in the second half of tomorrow?
I don't know. I feel like they're still missing some on 6.3 and 6.4. Like I don't know what I need to look
I don't
at.
know.
Like missing like
Conceptual,
conceptual
yeah.
understanding. So you think they're even ready for tomorrow?
I'm gonna use it as more of a formative assessment.
Assessment, okay.
I think they're more ready than not, but this will give us hard data.
So what should I tell you about the back half of tomorrow?